In this video, we're going to take a look how to add and subtract fractions. Now, when we add and subtract fractions, what we need to ensure is that we have a common denominator. So that's essentially the magic rule when you're adding and subtracting fractions. If you don't have a common denominator, then you can add or subtract those fractions. You need to do a bit of work to match those denominators. So, for example here, 3 over 4 plus 1 over 8, we can't add them yet, okay? We need to do a bit of work to make sure these denominators match. So if you take a look at this first example here, notice that they do have a common denominator. This denominator, so the bottom part of the fraction is 5. Same again here for this fraction, okay? But for this example here, we can't subtract yet because this denominator is a 2, this denominator is a 3, so we can't do the subtraction. So we've got 3 examples here that we'll work through together, and then on the next page, there's 3 practice questions for you to have a go at. So let's start with the most straightforward example here. So what I've got is 1 over 5 plus 3 over 5. And because we have a common denominator here, we don't need to do any further work. All we simply need to do here is add the numerators together, so the top numbers together. Now, don't fall into the mistake here of adding the denominators together. We leave the denominators as they are. So I'm going to do 1 plus 3 for my numerator, so 1 plus 3. So that's my numerator. And remember, the denominator stays the same. So the denominator here stays as 5. Then I just simplified the numerator, so 1 plus 3 giving me 4. And like we said, we just get 5 for our denominator. So 1 over 5 plus 3 over 5 gives us 4 over 5. Now, like we said here, we've got 3 over 4 plus 1 over 8. We can't add these together yet, but we can if we do a little bit of work. So here, I need to match this 4 and this 8 together. So how do we do this? Well, if the larger number, so 8 in this case, is a multiple of the smaller number, then we only need to multiply the smaller number. So what I mean by that is, does 4 go into 8? Well, it does if we think about the 4 times table. 4, 8. So in that case, I need to times this fraction here by 2. And like we said, we need to match these, so that's the reason why I'm timesing it by 2, because 4 times by 2 gives me 8. So make sure you times both top and bottom of the fraction. So times the numerator here, 3 by 2, that would give us 6. Then we do 4, the denominator, times by 2, giving me 8. So I get 6 over 8. Now we add on what else is left over, so that's 1 over 8. And here now, notice the denominators match. So in that case, all I simply do is add the numerators together. So we do 6 plus 1. Keep the denominator as it is, and then 6 plus 1 gives me 7. So we get 7 over 8 there, okay? And then for this final example here, we've got 1 over 2 minus 1 over 3. Now the issue with this one is if we think about the denominators here, well, they're clearly not common, they're not the same number. And the larger number here is not a multiple of the smaller number, so 3 is not a multiple of 2. So that presents us a new problem here. So how do we match these denominators? Well, there's a nice easy trick to doing this, and that is to take the denominator of the opposite fraction. So if we start with this 1 over 2 here, take the denominator of the opposite fraction, so this 3, and we take this fraction times it by that denominator. So 1 over 2 times it by 3, and then do the same with the other fraction. So 1 over 3 times it by the denominator of the other fraction, so that's 2. So we times that one by 2. Now again, make sure you times both the numerator, so the top number, and the denominator, so the bottom number. So 1 times by 3 gives me 3. 2 times by 3 gives me 6. So, oops, my pen has gone off. So 3 over 6. And then do the same here with this fraction. So 1 times by 2 gives me 2. And then 3 times by 2 gives me 6. And notice the magic here is that our denominator now has matched. Okay, so that saves us having to really think about it. It's just a nice simple way of matching that denominator. So now, just like we did with addition, once I've got a common denominator, then we just subtract the numerator. So I'm going to do 3 minus 2 here. So 3 minus 2. And again, we keep the denominator as it is. So 3 minus 2 is 1. So what I get here is 1 over 6. Okay, and that's our solution to the final example. So we've worked through 3 examples together. What I'd say here now is to have a go at these 3 practice questions. So pause the video, have a quick go, and then we'll take a look in a moment at what you should have got. So hopefully you got an okay with these practice questions. Let's take a look now at what you should have got. So for the first example here, the good thing is we have a common denominator, so we don't need to do any further work. All I need to do now is perform the subtraction. So remember, we subtract from the numerators here, so I'm going to do 3 minus 1, and we keep the denominator as it is. So I'm going to do 3 minus 1 giving me 2, and then keep the denominator, so I get 2 over 7. Okay. For the next one here, well, the first thing I notice is we don't have a common denominator. So now the first thing we do is we check whether the larger number is a multiple of the smaller number. So is 10 a multiple of 5? Well, it is, because if I times 5 by 2, we get 10. So that tells us that we need to take this fraction here and times it by 2. So 3 times by 2 is 6. 5 times by 2 is 10. So we get 6 over 10. And we're subtracting 1 over 10. So we minus 1 over 10 here. And now we have a common denominator. So in this case, all I do then is subtract from the numerator. So I'm going to do 6 minus 1, and then keep the denominator. So we get 6 minus 1 over 10, and then 6 minus 1 gives us 5. So we get 5 over 10 here, and we can take this one step further because we can actually simplify here. So the way to do that is to think about both the numerator and denominator here, and think about what's the largest number that we can divide both the numerator and the denominator by. And in this case, we can divide both top and bottom here by 5. So 5 divided by 5 would give me 1, and 10 divided by 5 would give me 2. And we get a half there, okay? So 3 over 5 minus 1 over 10 gives us a half. And then for this final practice question here, we've got 1 over 4 plus 2 over 3. Now, the first thing to do is to check whether the larger number is a multiple of the smaller. So the larger denominator, is a multiple of the smaller denominator. And in this case, it isn't. So 4 is not a multiple of 3. So what we do then is we take, say, this left-hand fraction here, and we times it by the denominator of the right-hand fraction. So we times that by 3. Then we take this fraction here and times it by the denominator of the other fraction. So we times that one by 4. So make sure you, again, times both top and bottom of both fractions here by their respective number. So 1 times by 3 would give me 3. 4 times by 3 would give me 12. Then we do the same with this fraction. So 2 times by 4, that would give me 8. So we're adding 8 here over 12. So 3 times by 4 would give me 12. And then here, because we now have a common denominator, we simply need to add the numerators together. So 3 plus 8 over 11. And then, that should be a 12. I'm accidentally doing the addition as my denominator. So 3 plus 8, like we've already seen, is 11. And it will be over 12 because we keep the denominator as it is here. Okay, and we get 11 over 12 there. So like you can see, adding and subtracting fractions isn't too challenging, but you need to ensure that you have a common denominator. So that brings us to the end of this video. In the next video, we're going to take a look at multiplying and dividing fractions.